Okay, for today's lesson, you will need to have with you your periodic table. So hopefully you have that printed out so that you can refer to it. And there may be some things that you want to add to your periodic table, or you may want to do some color coding. So also having some colored pencils or some highlighters would be a good idea for this lesson and the next lesson so that we can get acquainted to our new best friend in chemistry class, okay? So the periodic table is going to be our best friend. You're going to need to use it a lot. Okay, so let's start by talking about Dalton's atomic theory. So Dalton here refers to the scientist John Dalton. He was an English physicist and chemist. Okay, and this theory is named for him since he was the first one to eloquently state it and share it with the scientific community. So we have several parts to his theory here. Ready? All right, one part states that all elements are composed of tiny, indivisible particles called atoms. Okay, so everything on that periodic table is made out of atoms. Okay, atoms of the same element are identical. Okay, so this atom of copper and this atom of copper are identical. This atom of oxygen and this atom of oxygen are identical. Atoms of different elements can combine to form compounds. Okay, we learned about that in our previous units, how they can combine to form compounds. And then finally, atoms of one element are never changed into atoms of another element, right? So they cannot change their identity. And oxygen cannot turn into a carbon. Aluminum cannot turn into gold, right? There were lots of people way back when who used to try to do that. They used to try to turn things into gold, right? They were called alchemists and they studied alchemy, but that is not possible. Elements cannot change their identity. Okay, so let's talk about subatomic particles. What makes up an atom? There are three kinds of subatomic particles that we are going to study. If you are interested in things like this, when you go to college, you'll learn that there are things that are even smaller than the subatomic particles that make up the subatomic particles, but we're just going to go to this level. These three things: the electrons, the protons, and the neutrons. Okay? Electrons have a negative charge, so their electrical charge is negative. These are located around the outside of the nucleus. They're in constant motion outside of the nucleus. Inside of the nucleus, you have protons and neutrons. Protons have a positive charge. Okay, so that positive electrical charge, which means that protons and electrons are attracted to each other because opposites attract with electricity. Okay, and then you have neutrons. Neutrons have no charge, they are neutral. Okay, so neutrons, neutral, protons, positive, so the two P's go together and the two N's go together. Okay, and then the electrons are left over and they are the negative. Okay, electrons repel one another because negative and negative, they want to get away from each other. Same with protons. Protons repel each other. They want to get away from each other. So you have to have a good ratio of protons to neutrons to make a stable nucleus. Otherwise, the nucleus wants to fall apart because if there's too many protons, all that positive pushing against each other can cause a decay, cause it to fall apart. Okay, so how do we read the periodic table? So what I've done here is I've just blown up one box on the periodic table so we can look at the different parts that are in there. Okay, so the number that's in the top center of the box is the atomic number. This tells you the number of protons in the nucleus of that element, of the atoms of that element. And this number also gives you your identity. It tells you the identity of that atom, of that element. Okay, so atomic number, number of protons, also gives it its identity. Okay, so an element will always have that same number of protons. It may have different numbers of neutrons. It may have different numbers of electrons. We'll talk about how that happens as we continue moving forward. But the number of protons gives it its identity. Okay. Next, below the atomic number, we have the element symbol. This is the specific abbreviation for that element. And it is always this way. This is scientists from all around the world know the element symbol that goes with the element name. Okay, so you can't just pick. So this is either one capital letter, or it'll have a capital letter and a lowercase letter, right? Because there's only 26 letters in the alphabet, and there's more than 26 elements. So some of them have two letters. The first one capitalized, second one lowercase. You want to be careful as we're going through to make sure that you capitalize what's supposed to be capitalized and you lowercase what's supposed to be lowercase, because it can change the identity of what you are writing. For example, cobalt is capital C, lowercase o. Okay, that's an element. But if you have capital C, capital O, well, now that's carbon monoxide, and that's a compound, and that's something totally different. Okay, so be careful. Then we have the element name. On our periodic table, it includes the element name so that we can start pairing and learning and sort of memorizing the element name with the element symbol together. A lot of periodic tables do not include the element name because people who work with the periodic table and work with these elements and work with chemicals, they know them. They have memorized them, so they don't waste space by writing it out. But ours, since we're just starting on our chemistry journey, will have it written on there for you. It does have it written on there for you. And finally, at the bottom, we have the AMU, also known as the atomic mass unit, or the atomic weight. Okay, this is about how much this element weighs, and we're going to learn all about this as we continue to move forward. We'll add to this information. Okay, but to start with, simple, it's basically the protons plus the neutrons. Okay, basically the protons plus the neutrons. But we'll get more specific as we move forward with how that's going to go. Okay, let's talk about the big organization of the elements. So if we take a look at our periodic table, we are going to see one of the patterns is metallic character. Okay, metallic character. So here where I have yellow on my periodic table, these guys are metals. Okay, metals. So as you can see, most of the periodic table is composed of metals or metallic elements. What I have colored green here, these are the non-metals. So they are not metallic. And then we have what I have written in purple. This is along that dark stair-step line. These are the metalloids. These guys, it depends on the situation that they are in, whether they act like a metal or they act like a non-metal. So it depends on who they're going to interact with. Okay, we can also look at it in block formation. So what I currently have in purple, these are the main group elements. You will see as we work through the semester that these are the elements that we will work with the most. They will be the most common. We will see them the most because they're highly interactive, and so you see them coming up a lot. Then we have what's currently yellow is the transition metals, and as we continue to move forward, we'll see what kinds of special properties that the transition metals have. And then what's written down here in green, these are the inner transition metals. Okay, so we'll learn how to work with those in the future as well.